Okay, so this problem is writing mechanism. So you have been given reactant and you have been given product. So this is the reactant that is given to you. And if this reactant is treated with H plus in solvent water, the final product is this. And what you have to do is you have to write down the mechanism for the following reaction. So let us think for some time. So you see what is happening. You see there is a, if you see this reaction, there is a something like this OH, and finally you have only changes. So you have a O, so there is a ether is formed. It looks like H2O molecule has gone. So you have to see, what you have to see is you have to observe the changes. So what are the changes that is taking place in this reaction? You see, what are the changes that is taking place? So changes, you can say, it looks like 1 minus H2O. So that is removal of H2O. It is the change that is taking place. So removal of H2O. So this is the change that is taking place in this reaction. Are you getting? Now let us try to do this one. So how will you do this one? So let me make the molecule again, and then you can see. So you have a benzene ring here. So this is the benzene ring, and here you have OH, and here you have simply this OH, and then here also you have a benzene ring. So this is the simple things. Are you getting? Now H plus. So you have H plus. Now either you attach H plus here on this OH2 plus, or you attach here. Only thing is, in this case, the carbocation form that it will be more stabilized resonance to the benzene, but in this case resonance to the benzene, but this carbocation is primary carbocation, so it's better to protonate this OH group. So you have H plus, you have lone pair here, and this lone pair gives to the H plus, and then you get something like this. So you see, you will have this benzene ring. Things are easy. You have OH, and here you have OH2 plus. If you give H plus, then it will become OH2 plus, and here you have benzene. Are you getting or not? Now what you have to do in the next step, if you lose H2O plus from here, so what you will get? So if you lose H2O, one molecule of H2O, you will have something like this. So let me make this one. So you see OH, and here you have plus charge. This is a carbocation that is formed. And now you see this carbocation is basically resonance stabilized through the benzene. So this carbocation is resonance stabilized. So this is a resonance stabilized carbocation. So this is not a simple carbocation. So this is a resonance stabilized. Are you getting? Now what you can do in the next step, you have H2O, so it has two lone pairs, and this lone pair attacks on this carbon. So you will have, simply you can have this one, this benzene ring, and then you have this 1, 2, and then oxygen. So you will have oxygen. Let us count number of carbon 1. So this oxygen 1, carbon 2, 3, 4, 5, 6. So containing oxygen, you will have a 6-membered ring. So let us make a 6-membered ring, and carbon number 1 and carbon number 2. So there will be on position 2, you will have oxygen. This is position 1, this is position 2, you will have oxygen. And now you have to make a 6-membered ring. So this is the 6-membered ring. Basically this oxygen should be here. So let me make this, rub this oxygen and put this oxygen here, so that things will look nicer. So this oxygen is basically here. Are you getting? And at this carbon you have a pH group, benzene group, not pH group. So this is the benzene. Okay, this is also phenyl. So this is the final product you will have. Are you getting or not? So you check the product, you have to derive the same product or not. So if you see, this is the same product. Are you getting? So you have to derive the same product. So this is the mechanism for this reaction. Simple. First step is carbocation formation. So this is H plus, and this is a carbocation, and this carbocation is basically resonance stabilized. So you have to have a resonance stabilized carbocation, and then this H2O. So this final product is a ether. So this is a ether. Simple. Because you have over this side carbon, this side carbon. Let us discuss the next problem again. It's an easy problem. So we have a some writing mechanism kind of reactions. Writing mechanism is a good thing. So let us say we have this reaction, and you have to write down the mechanism for this reaction. What is the main task? You have to first look at the changes that is happening in the reaction. That's the one way. So writing mechanism problems, you have to see what are the changes that is taking place. So if you see this reaction, now you see there is a CH2CH3, so it looks like hydrogen has gone and you have a CH2CH3 group attached. So basically you have to add one CH2CH3 group. So it looks like I have to add one CH2CH3 group at oxygen. Are you getting it? So this I have to add at oxygen. So this is my hint. So we are discussing the solution of this problem. And now H2SO4 is a catalyst. You see this side there is no change, this side there is no change, only change is at here. So what can you do is, again, if you make a carbocation here, this carbocation is resonance stabilized through this ring as well as through this ring. Now sulfur also has a lone pair here. So let us say what you have to do is, first you have to make carbocation and then you can write a resonating structure of that carbocation, resonance stabilized carbocation. So you have a fluorine here. Now here you have OH and here you have a 5-membered ring. So this 5-membered ring, here you have a sulfur. So let us say you have sulfur here, so let me write this the sulfur, and then you have double bond here, and then you have one bond, and there is a double bond. So what is the thing, first step, you have to protonate. So let us say this oxygen, you have H plus, because H2SO4 will give H plus. So let us protonate this one. So if you do protonation, what you will have? You will have pH, one benzene ring that contains fluorine, and then you will have OH2 plus. Okay, not here. So you will have basically this is wrong. So I have to rub this one. Are you getting or not? So this is not here. Now you will have here sulfur, and here you will have, oh my god, again wrong. So I have to have here I have to have OH2 plus. So OH2 plus. Okay, good. Now here I have sulfur, and then 5-membered ring I have to make. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Are you getting it? 1, 2, 3, 4, 5. Now I have to lose H2O plus. If I lose H2O plus, so what you will have? If you lose H2O plus, you will have a bond something like this. So there is a fluorine. Also these things are very basically, there is no need to keep writing same thing again and again. So if you understand things, it is easy. So you have a 5-membered ring, there is a double bond. Are you getting it? So this is a 5-membered ring, there is a double bond also here. Now see, this carbocation, basically there is a hydrogen also. So this carbocation is resonance stabilized through this side as well as through this side. So I can say this carbocation, and that's why this carbocation is formed. So you see this carbocation is resonance stabilized. Resonance stabilized. So this is resonance stabilized. Are you getting? Simple. Now next step, we have to add CH2CH3. Now solvent, you see your solvent is CH3CH2OH, and H2SO4 is a catalyst. So you see next step, what you can do is you can attack oxygen of pair. So you have oxygen that contains lone pair. Now if you attack this oxygen here, are you getting or not? So what you will have, if you attack this oxygen here, and let me release this H plus in the same step. So if I release H plus, and so finally I will get the same product that we have to derive. Are you getting or not? So simple one. So you have to have, so let me write again. So you have a fluorine here, and then you have to have carbon, and then you will have OCH2CH3 group. So this is the thing, and then you will have here CH, and then you will have a 5-membered ring. So here you have sulfur, and then you have a 5-membered ring, and this sulfur also contains. So this is the final product. Important point we have, that is a resonance stabilized carbocation. This carbocation is a stable carbocation. So this is a somebody can basically isolate this carbocation in the reaction mixture. So the carbocation that is formed is a stable carbocation. Simple. Okay.